Hi, welcome back to Moose in Chemistry. This is Electron Configuration of Rubidium, RB lesson. Now, rubidium is the element number 37 on the periodic table, so we're going to put a 37 right here for our atomic number. And our atomic mass number is going to be 85. So we're going to write 85 right here. So we're going to have 37 protons, 37 electrons, because it's electrical neutral. But what about our neutrons? Well, we go AMU minus protons equals our number of neutrons, right? So we go 85 minus 37, and that's going to give me 48 neutrons. Pretty darn snarly, huh? So I'm going to write a 48 right here. So let me give myself a little bit more space here, and I'll erase this real quickly. There we go. Now, hey, let's look at our electron configuration. But when we do that, we have to remember that the S subshell can hold 2 electrons, the P subshell can hold 10 electrons, the D subshell can hold 10 electrons, and the F subshell can hold 14 electrons. We're going to use the off-ball principle, which states that we have to fill the lower shells first before we fill the upper shells, and we're going to do it by using the diagonal rule, which is this guy right here. So let's go ahead and start. 1s2, right? So we're going to put 2 right here. 2s2. So that's pretty easy, huh? 2p6, and then 3s2. Then 3p6, and then 4s2. 3d10, 4p6, 5s1. 3d10, 4p6, 5s1. Wow, that was pretty easy. Well, let's look at our orbital notation. Remember, our orbital notation deals with Hund's rules, which says that for every suborbit, you have to put an up arrow first before you put the down arrow. So let's look at 1s. Up and down. Pretty easy. 2s. Up and down. 2px, 2py, 2pz. Now we go down. See? And that's Hund's rule right there. Pretty cool, huh? And up and down again. And then we just keep going on like this. Pretty darn snarly. That's all I gotta say. This is so easy. Then you go 3dx squared minus y squared, 3dxy, 3dyz, 3dxz, 3dz squared. And then you just do the same thing. You go up, 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 and then you go down, right? This is really easy. And the same thing with the 4px, 4py, 4pz. Look at that. Look how easy this is. Now we're down to 1 electron left, and we go up with the 5s. Pretty snarly. Now let's look at the noble gas notation. The nearest noble gas to rubidium is krypton. So we're going to write Kr right here. Pretty amazing, huh? And then we're going to get our valence shell, which is this guy right here. We're going to call this Kr 5s1. Now let's look at our quantum numbers. Pauli's exclusionary principle clearly states that no two elements can have the same set of quantum numbers. So it's in the S block, right? It's in the 5th period. So our principal quantum number is 5. Our angular momentum number is going to be 0 since it's in the S block. It's going to be 0 for a magnetic number since it's in the S block, right? And look at our last arrow. Our last arrow here is going up, right? So that's going to be 1/2 positive. Well, that's it, guys. You be snarly, and we'll see you back here at Moose in Chemistry.